Nothing can escape the embrace of a force deep within the universe. They are the mysterious and enigmatic objects known as black holes. Black holes are incredibly dense regions of space where the gravitational pull is so strong that even light cannot escape. They range in size from tiny star black holes to supermassive black holes at the centers of galaxies. Join us as we explore the mysterious depths of black holes to learn more about these potent and mysterious phenomena. John Michell, an English astronomer and clergyman, made a brief argument for the existence of a body that was so massive that even light could not escape in a letter that was published in November 1784. According to Mitchell's crude calculations, which assumed that such a body might have the same density as the Sun, one would arise when a star had a diameter that is 500 times greater than the Sun's, and a surface escape velocity that is faster than the speed of light. These objects were described as dark stars by Mitchell. Before we continue, kindly click the like button and subscribe to this channel for more videos. To get alerts for new videos, click the bell icon. Have you completed this already? Let us begin. What is a black hole? A black hole is an area of space-time with a gravitational pull so intense that nothing, not even light or other electromagnetic waves, can travel beyond its event horizon. According to general relativity theory, a compact enough mass can bend space-time into a black hole. The event horizon is the line beyond which there is no escape, despite significantly impacting the outcome and circumstances of an object traversing it. General relativity states that it lacks any locally observable characteristics. A black hole behaves like a perfect black body since it does not reflect light. Additionally, event horizons are predicted to emit Hawking radiation, which has the same spectrum as a black body and a temperature inversely proportional to mass, according to quantum field theory and curved spacetime. For stellar black holes, this temperature is on the order of billions of a Kelvin, making direct observation virtually tricky. John Michell and Pierre-Simon Laplace were the first to think about objects whose gravitational fields are so powerful that light cannot escape. Carl Schwarzschild devised the first general relativity model to describe a black hole in 1916 adequately. In 1958, David Finkelstein published the first article defining a black hole as an area of space from which nothing can egress. Black holes were once thought to be a mathematical oddity, but theoretical research in the 1960s revealed that they were a general prediction of general relativity. Jocelyn Bell Burnell's 1967 discovery of neutron stars stimulated research into gravitationally compacted compact objects as a potential astrophysical reality. Cygnus X1 was the first black hole to be discovered, and it was done so independently by various researchers in 1971. Black hole discovery. In 1916, Albert Einstein's general theory of relativity made the first prediction about the existence of black holes. Many years later, in 1967, American astronomer John Wheeler first used the term black hole. Until recently, black holes were solely understood as hypothetical entities. Cygnus X1 in the Milky Way's constellation of Cygnus, the Swan, was the first black hole ever found. According to NASA, the first indications of a black hole were discovered in 1964 when a sounding rocket discovered astronomical X-ray sources. Astronomers discovered in 1971 that the source of the X-rays was a bright blue star orbiting a mysterious dark object. How do black holes form? A black hole is formed when a massive star explodes after its existence in a supernova explosion. The continuous fusion of hydrogen and helium produces the energy and light emitted by a star. A star spends most of its existence in a steady state because of the gravitational force drawing in and the energy the star is putting out balance each other. Stars like our Sun will continue to fuse elements like helium and carbon, as well as carbon and neon, until the end of their lives, but only for a short time. Giant stars will continue fusing different elements until the star reaches iron. Since iron is a very stable material, it cannot be further compressed by gravity. The pressure of energy radiating outwards and gravity pulling inwards become out of balance as iron accumulates in the core. When nuclear fusion's radiation pressure can no longer support the star's outer layers, the outer layers are drawn into the core by gravity. Now that gravity's pulling power is outweighed by the energy being released, the collapsing star explodes in a supernova, an enormous explosion ever recorded. The surviving core can produce a black hole while the lighter outer layers are launched into outer space. How well do we understand black holes? The existence of black holes is one of Einstein's theory of general relativity's most well-known predictions. According to the idea, a black hole is an area of space where gravity is so powerful that nothing, not even light, can escape. The physics principles that exist now are no longer valid because the gravitational attraction becomes unlimited within the event horizon. Black holes are believed to be essential to the development of galaxies. A supermassive black hole at the center of a galaxy can draw in enormous quantities of matter, generating a solid energy source. New stars may emerge due to this energy's ability to heat the gas and dust in the area. Additionally, high-energy jets that can span millions of light years are thought to form due to black holes. The strong magnetic fields seen nearby a black hole, which accelerate charged particles to speeds close to the speed of light, are assumed to be the cause of these jets. Black holes are still a subject about which scientists still know tiny. For instance, it is still unclear how black holes may expand to such massive sizes. Additionally, it is still unknown exactly what a black hole's singularity and event horizon are made of. Scientists now study black holes using a range of techniques, including observations with telescopes, computer simulations, and laboratory experimentation. There is still much research on black holes, and new findings are constantly being made. Recent discoveries of gravitational waves produced by the merger of two black holes by the Laser Interferometer Gravitational Wave Observatory (LIGO) have shed new light on their characteristics. The supermassive black hole in the center of the galaxy M87 has also been revealed in the first photograph of a black hole, which was taken by the Event Horizon Telescope (EHT). What aspects of black holes are still unknown to scientists? Scientists still have many questions concerning black holes, even though improved detectors and telescopes have revealed more information about them over the past few decades. What and how frequently do they eat? What transpires as things fall in? How much of it spills back out when it falls in? Does this eventually result in the black hole spinning? How are these dark holes initially produced? More fundamental queries include what is within a black hole and how are supermassive black holes connected to their galaxies, among others. The entire concept of black holes is ridiculous. According to Professor Holz, the argument that they cannot possibly exist is highly alluring. But both our ideas and our observations demonstrate that they must and do exist. Whether data that enters a black hole is lost forever is one issue that keeps scientists up at night. The information in a notebook may be recovered from the traces and gases left behind, as well as the light released, according to other physics principles that state that all information in the universe is conserved. However, from what we can gather, it is plausible that data in a notebook thrown into a black hole could be lost entirely to the cosmos. In conclusion, black holes are extraordinarily dense space areas with extremely intense gravity, preventing even light from escaping. They can be located near the center of most galaxies and are created by the collapse of massive stars. Black holes are significant in the development of galaxies because of their significant impact on the surrounding stuff. Despite significant advancements in recent years, there are still many elements of black holes that are unknown, and research into them is still quite active. The video for today is over. Remember to thumbs up this video and subscribe to the channel to see more. Remember to click the bell icon to get alerts when new videos are posted. With that, I will say goodbye and hope to see you in the upcoming video.